This is our first example of determining the components of a vector using a tilted axis. So notice here, they've labeled the axis for us. X being up here means they're saying up this way means positive x direction. Anything that points down this way is negative x direction. Here's our y-axis. By labeling the y up here, they're saying this direction is the positive y direction, and anything pointing this down this way is the negative y direction. So remember, in a tilted axis, we're talking about going from our original traditional coordinate system and rotating to this new axis that is tilted. The angle here that we have to rotate through is always the angle of the axis, and here it's directly drawn for us as 30 degrees. So if we had to rotate our original axis upwards by 30 degrees, then we had to rotate the original y-axis by 30 degrees. We had to rotate this negative x portion of the axis down 30. We had to rotate this y-axis, the negative y-axis, to the right by 30. That comes in handy in terms of drawing out this vector. Because this velocity vector over here is pointing in the original negative y direction, but this is our new y direction, I can say this is the y component of this velocity vector. To draw the x component of the velocity vector, I need to draw from where I just ended y over to the vector itself, the velocity vector. And this x component and y component need to meet at a right angle, 90 degrees. When I draw the angle, I'm essentially comparing the angle between something that points straight up and down and something that points at this new direction. That's why I know that angle is 30 degrees. This angle in here is 30 degrees. That's why I find it easiest to draw that particular triangle. So we can say the x component of this velocity, I suppose what I could say is v sub x. It's a velocity, and then use the subscript to represent that we specifically mean the x component. Because this has to point towards or down the tilted axis, this is going to be a negative value. Again, when they label the x up to the right, they mean up to the right is positive x, down to the left is negative x. So this x component of velocity pointing down to the left means it's a negative value. When we know we have a right triangle, like we do, we've intentionally drawn it that way, we can use sine of theta, cosine theta. So this x side is opposite the 30 degrees. So I would say sine of 30 degrees is equal to the x side over the hypotenuse, which in this case is 100 meters per second. So solving for that, I can ultimately say the x component of this velocity is negative 100 sine 30. I can never remember whether it's sine of 30 or sine of 60 that gives me 1/2. That's 30. So we can, in this case, say the x component of this velocity vector in the coordinate system they've supplied to us is negative 50 meters per second. So this is our answer for the x component. For the y component, this side we are adjacent to that angle, so we can say the cosine of 30 degrees is y over 100. The y component of this velocity, the direction, we're pointing this way, away from how they've labeled y, that makes this component the negative direction in this new coordinate system. And then solving this cosine, we can say it's 100 cosine of 30. So the y component of the velocity ends up being 87 meters per second. This particular problem is asking for components, so we're done. Here's my x component in the coordinate system given in the problem. It points in the negative x direction by 50 meters per second. Here's the y component in the coordinate system given. It points in the negative y direction and at 87 meters per second. So any type of vector, this case it's a velocity vector. A velocity vector is going to potentially have an x component and y component. If we wanted to, we could say that this velocity is minus 50 I hat minus 87 j hat meters per second, specifically in the coordinate system given in the problem with this tilted axis.